Alright, in this video I just briefly want to talk about the squeeze theorem and do a couple examples. Okay, so the squeeze theorem again deals with limits. So suppose in our picture we have our function here f of x, and suppose at the x coordinate of a we have the y coordinate of L, and then suppose we have another function, let's call it maybe g of x. Okay, and notice that at the x-coordinate of a, f of x and g of x intersect, okay? And so what we have right now in our squeeze theorem result, going that direction, what we have here so far is that we've got a function, f of x, that's greater than or equal to a function g of x, and we're going to squeeze something else inside of there. And notice we have that the limit as x approaches a of g of x, that equals L, and that's the same thing as the limit as x approaches a of f of x. Okay, so the idea with the squeeze theorem is, suppose we have some other function that's trapped in between there. Okay, so suppose we have this result, so what we can say is, if we call the red one, we'll call that maybe h of x. So what we have is, h of x is greater than or equal to g of x, but it's less than or equal to our function f of x. So the idea is, what can we say about the limit as x approaches a for our function that's in between there, h of x? Well, since it's squeezed in between the function f of x and g of x, we can say the limit as x approaches a of h of x must also equal this value of L. Okay, so the idea is, if the big function f of x and the small function g of x are getting squeezed together and have this limit L, and h of x is in between those two functions, then it must also have that same limit of L. So let's just do a couple quick problems here. So the first one here, it says if f of x is less or greater than or equal to 3x, but it's less than or equal to x cubed plus 2, and we have the property that for all x between 0 and 2, this relationship holds, and then we want to evaluate the limit as x approaches 1 of f of x. Well, the idea is, if we want to calculate the limit of the middle part, we can just calculate the limit of the end parts. So we'll look at the limit as x approaches 1 of 3x. Well, we can just plug in and get that to be 3. If we look at the limit as x approaches 1 of x cubed plus 2, the one on the outside, again, if you plug 1 in, you get 3. Well, since we have the limit as x approaches 1 of 3x is going to be less than or equal to the limit as x approaches 1 of f of x, and that's less than or equal to the limit as x approaches 1 of x cubed plus 2, we know that these outside values are both 3, that's what we just calculated. So it says, well, the limit of the stuff in the middle would have to be greater than or equal to 3 and less than or equal to 3, which obviously would imply, by the squeeze theorem here, that the limit as x approaches 1 of our function must also be the value of 3. Okay, so let's do one other one here, one other squeeze theorem problem. Okay, so here we're going to find the limit as x approaches 0 of x squared times cosine of 1 over x squared. Okay, so we're going to find this limit. Now notice we can't just plug in the x coordinate of 0, because if we plug in x equals 0, we'll get 0 times cosine of 1 over 0. And 1 over 0 is undefined. Okay, so we can't just do that. But what we can do is, we know that let's see. So we know that cosine of 1 over x squared, cosine of anything is in between -1 and +1, right? No matter what we plug inside of here, cosine always satisfies that relationship. Well, what that means is, if we multiply the inside by x squared, it says x squared cosine of 1 over x squared would always have to be greater than or equal to negative x squared, but it would have to be less than or equal to positive x squared. Okay, so in the last problem, we were kind of given the outside functions. The middle part was squeezed in between. In this problem, we have to come up with them on our own. Okay, so sometimes that'll be the tricky part. But now we notice that the limit as x approaches 0 of negative x squared will be less than or equal to the limit as x approaches 0 of x squared times cosine of 1 over x squared. And that's less than or equal to the limit as x approaches 0 of x squared. But obviously we can just plug in x equals 0 on our outside parts, and we'll get that the limit as x approaches 0 of x squared times cosine of 1 over x squared is greater than or equal to 0, less than or equal to 0, so we can make the conclusion that this limit that originally we were interested in also equals 0. Okay, so this is the basic idea of the squeeze theorem. Again, sometimes coming up with the functions will be the tricky part. A lot of times if you have cosines and sines floating around, you can bound them between -1 and +1 and kind of use that to your advantage as in this problem. So kind of a common little trick. So I hope this makes sense and helps you out. If you have any other questions, send me an email and I'll try to get to them if I can. Okay, good luck.